Okay everyone, I'm going to do a quick review of the stuff that we've covered so far and then also get into parallel line proofs. So essentially we're looking at parallel line proofs. Okay, so far from grade 7 you learned that opposite angles, that's your proof, are equal. Okay. I've used a bunch of different ways. Look for that X shape. Also think of it as two little fish kissing. Whatever you want to do, you got to figure it out. Next one was complementary. So two angles that fit within a 90 degrees. So those are complementary, and those add to 90 degrees. Okay. Then you also did this guy. So two of these are supplementary, and they add to 180 degrees. We're going to keep going. Then we got into triangles. So if I have two angles, I can find the third, right? That's SAT, which everything, whoops, I'm going to take those. All angles add to 180 degrees. If you know that you have an isosceles triangle, so it looks like that, or I'll even put it on its side so that you can see. Remember that the two lines that are congruent, they join at the vertex, okay? And that means that the two angles that are equal are the other two angles, okay? So, whoops, two angles are equal. And then that is isos. Okay, I didn't put SAT in brackets. And then the last one, the easiest one, but sometimes you get thrown that one, is equilateral, knowing that all sides are the same, which means all angles are the same. All angles are equal, and that gives you, whoops, equal. Okay, so I think I covered them all. I'm trying to go fast here. All right, so now we have two parallel lines. I'm sketching these, so I'm going to tell you that they're parallel by sticking that on there. Parallel lines, they never meet. Okay, that's point number 1. And point 2, they're always the same distance apart. So think of railway tracks. Okay, so those are our parallel lines. If I want to label this, I can call A, B, and call this C and D. And I can say that AB is parallel to CD. So this is the little symbol for parallel. Okay. If you have something like this, or even going through, right? A, B, C, D. I know it's a mess, but I just put that little box there. So now you know that it's a 90-degree angle. So this is perpendicular, just to keep it clear, right? And now I have to say that AC is perpendicular to BD, okay? Or you can reverse the letters. It doesn't matter when you're dealing with lines and line segments, okay? Next, we're going to come back to our parallel lines, and there's a special line that cuts through them, and this is called a transversal. Now, it can cut through just one as long as it meets the other. That's not very good, but it can cut through in that direction. It can even go through where there is a 90 degree, but you know that those are perpendicular. But those blue lines, That one's really wiggly. Those blue lines are still considered transversal, or it can cut all the way through. So you have to kind of look out for, again, those key symbols. You always have to find those little guys, okay? So, I hope I'm speeding through this at a rate that is good for you. So I'm going to try and show you a couple things. Make sure that you're on the Khan Academy. You know, either watch his videos, watch this one, something. The only thing that is a problem for me is that I can't really move things around on this technology, because then I could sort of overlay stuff. I haven't figured that part out yet. So we're going to go back to our parallel lines. Okay, I'm going to cut it with a transversal, and again, it can go in any kind of angle. The first thing I want to do is remind you that, remember, we've got our two fish kissing, or we've got that X pattern. So you've already done this, but don't forget, I've gone through those other relationships with you at the beginning, because those can be found in these as well. So that's your opposite, okay? And remember that they are equal. Okay, so that's the first thing. So find that little X pattern. You're not going to tell me that your proof is X. Your proof is still op, but look for an X, or look for those kissing fish. The next thing that we want to do is look for, we can start with this one, because this is the happy day. This is the only one that requires any kind of calculation with those parallel lines. Okay, these are called interior. You might also see them as co-interior, but interior is fine. So your proof is int. And these guys add to 180 degrees. And the way that I could show you is, I'm going to use the highlighter for a second. If I move this line up to match with the other line, it's going to place, so I'm sliding this bottom line to sit directly on top of that top line, so the parallel ones, and that means that this angle is going to sit right up here. And if you look at my highlighted angle plus my original red angle, and you cover up all the rest of that stuff, and I can't cover it up for you, or it's not going to show up for you, you can see, hopefully, that those two are supplementary to each other. So going back to what I would like to show you is that these interior angles add up to 180 degrees, and you can also find a C pattern. And again, this goes backwards as well. So, you know, I'm going to show you that in there, but I don't want to completely color in the whole diagram, or it takes away from the point. So, quick summary, right? If this is, if this one's 45 degrees, then that is also 45 degrees, right? And again, hopefully you can look at that and know that it's not 45. It's probably closer to 80. 75, okay? If we want to look at this one and say, okay, well, if this is 60 degrees, so I might give you that as an angle that's labeled, and I might say find angle A. So you're going to do the A plus 60 equals 180, because you know they add up to 180. And then we're going to say A equals 180 minus 60, which means angle A equals 120, and I know this because of interior. So that proof is, what do you know? Like, what do you actually know? So all of this stuff is the mathematics around it, but this is saying I'm proving it based on this angle property, okay? So we've got X, we've got C. Now we're going to do another one. So again, no more calculation after that. Everything else, angles are equal. So again, they don't look parallel, but I'm telling you they are. And I want to plot that guy and that guy, okay? And again, if you sort of take this line, okay, and you're going to put it on top of that line, you'll notice that the angles that are formed are below each of those parallel lines, which means that I can say that that angle, like the top angle and the bottom angle, are actually congruent to each other. They're equal. So let's come in and call this, I don't know, we'll call this one 110, right? And we'll say that this is B. So these are called corresponding angles. Okay, your proof is core. And they are equal, they're congruent. So I could say that angle B equals 110 degrees because of corresponding. If I knew another letter, then I could say angle B equals angle Z or something like that, which equals 110 degrees because of corresponding. So the cool thing for this one, hopefully you've seen the letter pattern. I don't know if you have, but if I come across here and I go straight down that transversal, my two parallel lines make an F pattern, and you'll notice that it's always kind of, I say, in the armpit of both of the lines that make the F. So this is an F, okay? The other one was C. I don't think I wrote it on there. The first one was X, then there was C, now there's F, and we're going to get to this one. And then we have one more. This is your last letter pattern. So again, these are parallel. I'm going to look at this angle in here versus that angle in there. Okay, and again, if I take this line and pull it down, you'll notice that the angle ends up there. Okay, I didn't show you on the other one, the angle ends up there. So the angle ends up on that side, and then you'll notice that you've got that opposite relationship happening again. Okay, so these are called interior, whoops. These are interior alternate. Interior means inside, and alternate means something's alternating. So it's like a pattern can alternate black, white, or blue, green, or star, circle, something like that. In this case, the alternate is, let's call it left, right. Okay, so the proof, you guessed it, guys, int alt. Okay, these are equal because we've already proven that based on that angle measure. So say for instance, this angle is, I don't know, 85 degrees, then this angle will also be 85 degrees. Okay, and then here's your last letter thing. If I do that, I come down the transversal and I come across, it's making a lovely little Z. Okay, and again, forgot to tell you, but that Z can go backwards and also back up here to the F. The F can go backwards, the F can also go upside down, and it can go upside down and backwards. So there's a lot of F's happening, so you've really got to look out for things. Last proof. This one. I'm going to put the transversal the other way this time, just for fun. Again, I'm telling you they're parallel, so they are. I'm going to plot two angles. One's going to be here, and the other one's going to be there. And again, if we get our little highlighter tool, and I highlight this, and I say, okay, I'm going to take this line, and I'm going to bring it all the way up to the top. If I slide that up, this angle at the bottom here is going to be over here. Okay, so, oh, I did that wrong. If I slide the line up, the angle's going to end up here. I put it in the wrong place originally. I don't know if you're going to see that though. So what this is called is exterior alternate. So you'll notice that it's similar. So exterior is outside. Alternate could be that left-right. We're alternating between left and right. Okay, so your proof, X'd, alt. Because when we move it up, you see that opposite relationship happening, so you know that those angles are congruent. Now, the thing that you're looking for is here and here, or obviously on that side and that side, but I don't have a letter thing for you to find, so it's just the pointy stuff on the outside. So I'm just going to do a really quick thing to show you the difference between int alt and ext alt. Okay, so let's go. Int alt is my Z that I'm finding. My calibration just suddenly went off. Int alt means that we are, is that my highlighter? Yes. We are inside of the parallel lines. Okay, int means inside, right? Interior means inside. So we're inside. And then we're alternating left and right, okay? And then if we want to look at ext alt, parallel lines again, even though they're messy, then what I'm looking at is an angle there and an angle there, and we're going to see that this is exterior, okay? Exterior, and then that guy is on the left of the transversal and that guy's on the right of the transversal. If I was to have two of them on the left, say the other angle's there, then I get that corresponding relationship. If I have an angle out here on the left side as well, it doesn't match up with that at all with the proof. You just have to, like, there's other ways around doing that. There's no proof for this and that on the outside, so you would do it by gaining access to it with the other proofs. So I'm gonna do a really quick one. I'm trying to make this as short as possible. I notice my videos are way too long, so I know you guys probably check out after a while, and that's okay. I understand. So again, parallel, total mess. That's all right. So what if I wanted to find a B and C, and I can get away with this by just telling you that this one is 80 degrees. Whoops, that's a mess. Okay, so the first thing I can do is look at 80 and A, and I'm just going to isolate it for you because I can't cover it over and show you. But I'm going to isolate this, and all I'm looking at is 80 and A, okay? 80 degrees. So the first thing I'm going to do is look at that and say, hey, that's supplementary. So I'm going to say angle A plus 80 equals 180. And then I'm going to say angle A is 180 minus 80, which means angle A is 100 degrees, right? Math? Yes. And that is because of my supplementary rule. Okay, so now I know, and I tend to do this a lot, I write in the stuff that I need to see in order to kind of help me out here. To get from A to B, I can't really do anything in terms of the proofs that I have, but what I could do is I could come up with D on my own and say, hey, wait a minute, I know that, and I'm going to mark this up for you, so I hope it doesn't get overwhelming. I'll use different colors. But there's that F rule happening. Notice that it's backwards and it's upside down. actually it's not backwards, sorry, it's just upside down. So now I know that in the armpit of that F pattern, I have angle A and I have angle D. So I can come in and I can say, whoops, angle D equals angle A, because I know that angle A equals 100 degrees, whee! And I know this because of corresponding, because that's my F pattern. Okay, and then again, Greenhill's gonna fire that in. Okay, I didn't have to actually do that. I just realized I could have done that with B. So I could say that angle B equals, that's the faster way. So the thing about these angles is, it's however you see them, you might see it differently than I do, but as long as you have your proofs there, I just realized that I could have just done corresponding there, and it would have been faster, but hey, no harm, no foul, doesn't matter. So B equals 80 degrees, and it's not like I can't really say that it's corresponding to a letter unless I want to put in another letter above that 80. So I'm just going to say B is 80 degrees, and I know that because of corresponding angles. So I'm going to come in like I tend to do and label up my diagram. And then I also know that angle C is equal to angle B that I've already solved. And I know that it's 80 degrees, and I know this because of opposite. Because what I'm doing is I'm looking at this here. Okay, so that's all I have. That's all that's required of me to solve. I could have given you like one angle possibly and asked you to solve for all of them, but that's just cruel and unusual punishment. I'd rather you just sort of get to where you're going. So your homework is make sure that you do the practice questions on the Khan Academy. It doesn't ask for any proofs, it just asks for numbers to be plugged in. But also continue on the slideshow. I've given you a rundown of all of this stuff, just typed out obviously, and I've given you one big example of a whole bunch of things integrated together, and it's overwhelming, but try to read through my little steps and maybe see if you could have solved it a different way with other information, because again, there's a lot of ways to approach these complex diagrams. And then I've given you only two questions to practice on your own. So try and get those done for Friday. And Friday, we're going to do more practice with this. Parallel lines take a little while to kind of get the juices flowing and feel a sense of confidence. So please, please, please message me if you need help. It is a pretty tricky thing, especially if you're what I call spatially challenged. Like if you struggle kind of visualizing and turning things over in your mind, it'll get tricky. Okay? See you soon.